let's take a look at Unit 4. This one is what I call coordinate geometry. By standards, they call it geometric properties with equations. That's where you get the G, P, and the E here. This one is just all things coordinates, and I really like this. It's a little deeper, a little heavier than the typical content in geometry with the algebra. I do a few things here that mix it up. I actually do this last in the year. I use it as a beautiful review of all the things that we've done just in the generic plane, and then finally we jump on to the coordinate plane at the end of the year. And there we bridge nicely geometry into the algebra. Students always in Algebra 2 say, oh, I don't remember anything from geometry, or 2 years ago from Algebra 1. This is a nice review of those things. It's a nice review of the year of geometry and so on. I also, right before this one, do Unit 5, which is circles, because when I finish circles, I pick up here with the equation of a circle. Again, a beautiful bridge into the next topic. So, equations of circles, nice. Equations of parabolas, and working with parabolas. Then this topic here is quite wide range. It just basically says solve a number of problems about the coordinate plane or using the coordinate plane. This can be about equations of lines. It can be about solving whether a point is in, on, or out of a circle. It can be lots of things here. A wide variety of good problems in there. Then we get into parallel and perpendicular lines. Actually, maybe let me just speak to this. This kind of hints towards coordinate proof as well. I actually move this up one just so I have all the control of parallel and perpendicular concepts heading into coordinate proof so that I can say, oh, that's a rectangle, for instance. If I gave you 4 points, could you determine if it's a rectangle or a parallelogram and so on? And then we partition a directed line segment. That just means to take a line segment and then put it in a ratio of, say, 2 to 1 or whatever. This actually is basically dilation review because we've already done that idea of reduction, and that's what a partitioning a segment would do. Is if here's your A, B, you partition it in a 2 to 1 ratio, your 2 to 1 ratio puts your point here, which is a form of a reduction in a dilation. And then we've already done some talking about perimeter and area, but this is in a coordinate setting, so you're going to get into Heron's formula. You're going to get into just finding area based off of the specifics there.